Mix it in.
What do you want for?
No, you only
I'm
can get
still trying to figure this out.
Yeah.
What do you want for? When it says square feet, do you have to have a square in the equation?
No, you just have to find the area.
Right, because number 73 or 72 is impossible because negative 9 over 2 is an impossible number to figure out.
It's not impossible. What about the other? What else could H be? 4. So that's fine. You got one part that was impossible, sure, but you still found the answer.
Okay, good. Could you do number 74?
But I got stuck in one. I couldn't keep going.
So what does it take 2 to multiply by 1?
But the drawing, we don't have 76. 76 drawing. 76.
There it is. There it is. Okay. That's what I was trying to find something.
Yeah, I can't remember how many of those Alright guys, so these problems from chapter 6 are all about factoring, right?
Right. All factoring, yeah.
What do you need before you can add 2 fractions? Before you can add 2 fractions?
Multiply it by the reverse somewhere?
No. What do you need? You need the like denominator. Right? So the whole idea there is, if a bottom can be factored, you factor it and you see who's missing what.
Right.
Right? So I always give people that just add them, even if they don't have the same denominator, they still somehow find a way to put them together, which is a neat new branch of mathematics, but I don't think you want to create a whole new branch of mathematics, maybe.
What they're missing. You time together what they're missing.
Yeah, you give them what they're missing. And then the other problems there were part C and D were multiplying or just reducing.
Right.
So you just had to take each piece and factor it. They were like several factoring problems.
Right.
And then how do you solve an equation with fractions in them? You get the bottoms to be all the same.
Right.
And then you multiply by that and they all gone. And then you're back in chapter 2. Right.
Then you can check your answer.
Yeah, then you can check your answers. Yeah. You got to make sure it doesn't freak it out, right? All right, but as always, there are a couple opportunities to increase your grade on a quiz, or you can correct it directly, and then if you do good enough on the corrections, do better on the test, it'll bring that grade up, right?
Right.
Quizzes, that's why I like quizzes are just a gauge. They say, this is what you should know. And then you go, oh crap, I don't know it. All right, I better freaking know it because the test is coming. The test is the one that means a lot more, right? All right. So I do have let me go ahead and give you this practice test so I don't forget.
It's next Monday, isn't it?
Before you guys leave.
Wednesday.
Next Wednesday?
It's not the final?
Test?
So a week from today. What's
Get out of
happening
here
on
early.
Monday then? Right.
Review test.
I can't believe it's almost over. This is I
Couple weeks.
Monday is review test.
We review the test, and then we have test 3 on Wednesday, and then the following. Yes,
Actually, that's the last one.
that's the last test, and then we have a final.
But don't we still have to go to the quadratic formula and more stuff? How we done?
Yeah, thankfully we have one more day to lecture.
Because I never learned that. Last class, the teachers kept that. I forgot about that. I thought I would learn it here.
We will, don't worry. I can't let you out of here without talking about that.
Okay.
We're going to talk about it today, actually.
Well, it's not that difficult.
So
Are we getting into the quadratic?
Good for the technical.
if you understand the concepts on that practice test, then you should do well on the test.
Okay.
Good. Okay. Be really careful, as always, that you don't overstudy a specific problem. Right? The first time I gave a practice test, the first time I ever taught, somebody knew all these problems and said, I worked your test for 8 hours. I worked that test. And I redid every problem. I knew every problem, and then I failed your test. I'm like, well, yeah, you would pass this damn test. You wouldn't pass any other test because you didn't understand the idea behind these, right? So that's the whole idea of math. What is the idea? What do I have to try to do on this problem? Okay, so fraction. I need LCD. There's variables in there. Oh crap! Okay, I've got to break them down so I can see what they're made of. Right? It's the idea that carries you through, not the specific problem. Okay. question? Any specific questions from
Yeah.
anybody else? Chapter 7 homework?
11.6.
Yeah, which one is which one's
73.
today's slide? 73. What do you do? What do you think? Let me give you one like that one. I even like that one better. When you're presented with a function that you don't know what it looks like, what's the most basic approach to try to graph it?
Freak out.
Is it an equation of a line?
No.
Why not?
Well, actually, you know what? Yeah, it could be.
It's the square root of x. It's x to the what power?
A minus.
Is that a
That's the third.
Be careful here. Everybody understand this is a 3?
Square.
So x to the 1/2. A linear function has x to the first. That's why I call it linear. It's the first power. This is 1/2 power. It's not going to be a straight line. It's going to be some kind of curve.
It's going to be a parabola, right?
No.
No.
So, what's the most basic way to try to graph a function if I don't know what it looks like?
Are you going to give 2 points like
x equals 0 and we
Yeah,
find y.
just start
2
getting
points.
points.
XY
right? Make a
table,
little
right.
XY table. Now, what can I not plug in there? What's the lowest thing I can plug in here?
1. You can't plug
Lower
0.
than that?
0.
0.
Well, you can't have a square root of 0, can you?
What does it take 2 of to multiply by 0?
0.
0. Okay, so square root of 0 is 0.
Any number in
3
0
times 0 is 0 minus 2.
is negative 2.
How we doing so far?
Say that again?
Alright, so 3 times square root of 0 minus 2.
Negative 2. Okay,
Square root of 0 is 0 times 3 is 0 minus 2 is negative 2.
Okay.
I always love when that 3 stays alive somehow. It's dead, right? What's another? I can plug a 1 in.
1.
Yeah, 1.
So what's 3 square root of 1 minus 2? Square root of 1 is?
3 minus 2. It's
Square root of 1 is 1 times 3 is 3.
1.
Square root minus 2 is 1.
1, 1.
Okay.
I'm not going too fast here, am I? All I'm doing is plugging stuff in and then work it out. Now, would it be smart to put a 2 in there?
No.
What's the next smart number to use?
4.
4. Why? Because you can take the square root of 4, right? So I'm going to skip 2 and 3. I don't have to do every damn point, because how many points have I already skipped? An infinite number of points I skipped. What about point 0078? Screw that. I'm just going to do the ones that make sense, the ones that come out with pretty points, and then I'm just going to connect them. So what's 4? 3 square root of 4 minus 2. Square root of 4 is 2. 2 times 3 is 6.
So it's 4.
I love you, Yasmin. You're awesome. Square root of 4 is 6. No. One step at a time.
I'm going to guess any number that has a square root is going to be the same number for x and y at this point. If you
0 wasn't 0 there.
Oh, 1 and 4.
In fact, if we do
That's what
one
I'm
more, I'm not
getting
going to plot this point, but if I plug a 9 in there, when I get 3 square root of 9, times square root of 9 is 3.
Minus 2 is
Times 3 is
1.
9, minus 2 is 7.
7.
So
Okay.
then-
I guess I was.
I like that, though. You notice that these are the same, but
Yeah.
this is not the same. Now you just plot the points. So your idea of it being a parabola is sort of right, but it's sort of like a parabola that fell over and lost half of itself.
Oh boy.
What's the first point? 0, negative
0,
2.
negative 2. So just, and then up 1, over 1, up 1. And over 4, up 4.
No, don't think about it like that. 0, negative 2. The next point is 1, 1.
1 and 1.
The next point is 4, 4. And then it's 9, 7. So now see how it's going like this?
It's going to be a curved line, in a sense.
I like that, a curved line.
Or am I off?
Or just a curve.
Just a curve. Then.
Notice how it doesn't go here.
It's an arc. Then.
Why can't it go there? Because I can't plug in
Negative.
negative numbers.
Because
Right.
negatives don't have
Or
a square
x.
root.
Yeah, exactly. So anywhere x is negative, it can't exist. It can't be there.
No negative square roots, Chris.
Every single square root is going to have a basic form like this. That one's just been moved around, hasn't it? I moved it down by 2. See, that went down 2. And then I made it 3 times as big as normal. Right? But every single square root has a shape like that. Just like you guys already kind of know that parabolas, x squares look like that. And they can be moved around if I add 3 and subtract 4 or whatever.
So what is this line called? An arc or something?
No, we just call it a curve. I like the arc though. You can call it whatever you want to personally, but we'll call this a curve.
Curved line.
Curved line, I like it. Well, in math we have a straight angle, so.
So it starts at the 0, 0, 2, -2 point?
Yep.
That's where it starts.
Yes.
So what about the curve? Does it continue to curve down, or does it just
Careful now.
go straight?
What do you think? As I put bigger and bigger numbers in here, the output's going to keep getting.
Bigger.
But notice how it's growing, but it stops growing as quickly. It's always growing, it just isn't growing as quickly.
Okay.
The current.
So it never becomes flat.
Right.
Because every time x gets a little bigger, y is going to get a little bigger. Very little bigger, right?
The curve just decreases and decreases and.
Yeah, cool. I love it. So it doesn't decrease, but it just increases less and less.
Okay.
Okay.
To a
So you
less
hear this all the time in the
noticeable
news. You hear stuff like the rate of decrease in the economy is going down. You know what? It's the amount that is going down is not as much as it was before, right?
That stinks.
So it's talking about it's
Right.
still going down, just not as much. So it's still going up, just not as much.
Riding away.
As it goes and goes. How are we doing? All that crap I just said is unnecessary, really. All you got to do for graphing, whatever they give you, is just start plugging numbers in that make sense. One last example of this, and this is a really good example here.
So we're back to chapter what? With this.
What makes sense to plug? Can somebody give me a number that would make sense to plug in there?
2.
2. Why?
Because the square root is 2.
Square root of 2 is
Because
1.
2 plus 2 is 4. Now you got to think.
Square root of
I don't want to plug 4 in. 4 would suck. Because
Yeah.
you'd end up with what inside?
Yeah.
A 6. So yeah, now I got to be doubly smart. I got to think. Okay, like a 0 sucks, but 2 is good.
Yeah.
Square root of 2 plus 2.
7 is
Square root of 4 is 2.
Why wouldn't?
7 is good
Yeah, 7 is good.
Why
because it's going to end up with 7 plus 2 is going to end up with 9.
Yeah. Okay.
3.
What about negative numbers?
Can't do it.
I can do it. Negative 1.
What? Oh, because you're not square root.
Negative 1 plus 2 is square root of
1.
1. What about negative 2?
It'd be 0.
Square root of 0, which is 0. Can I do anything below negative 2?
No.
No.
You guys see why? Anything below negative 2 is going to make the inside negative.
That's the restriction?
So it seems to me a good place to find is the number that makes this 0. That seems to be the starting point, right?
I'm glad you clarified because I said, why don't you just square root the numbers inside and then add? But as you said, you can't do that.
You can't do that. Square roots don't play with pluses, right?
Order
Square
of
roots are powers. They don't play well with addition.
Order of operations, correct?
Order operations, save your ass. Okay, and then you can plot the points.
Yeah, yes, they do.
It's easy now.
What section is that?
That is the last part of section
7.6.
7.6.
7-6.
Any other questions from the? That one I'm not really that concerned. I wanted to give you a couple problems just so you saw what the shape of a square root was. But it's really just making an XY table and putting the points in.
So
Really not that
the
bad.
shape of a square root is a curve, and the shape of a square is going to be a parabola.
Yeah, notice how this looks almost parabolic. It's just like a parabola that fell over and the bottom half fell out. Because the square root is the opposite of a square. They should kind of look similar. Just one is inverted from the other one. All right, so here, chapter 7 questions.
We're going on to
I'm
chapter
not
8.
sure what the hell this is, but I just do it all.
Chapter 8,
I like
then?
this too. So I'm just pointing that out, Jeff. You're always doing this. All right, so if there's no other questions,
7,
I'm
7.
hoping that's for the right reasons. It's cool. We're gonna finish out chapter 7 and do a little bit of 8. That's the plan for today.
7, 8 is required.
Say again?
7, 8 is required.
7, 8.
You don't have it on the
no 7.
revised homework.
Oh, no, it's not one.
There is no
That's
7, 8.
one.
No.
Okay.
That's fine. Make it up.
Invisible 7, 8.
But there is 7, 7.
All right, guys. Here we go.
Jeff, our math books are playing tricks on us.
I love it. Some of my classes don't say a word. You guys have a lot of noises. I love it. Don't get me wrong. You gotta keep on track too. So 7, 7.
4,
This is the much anticipated. What the hell would it mean to not be a real number section? Right. So these are what's called
Imaginary number.
complex numbers, which are composed of imaginary and real.
Pseudo math.
And this is where some people just kind of shut me out. That's all right. I'll try to get back in there. a lot of times in mathematics, when you first learn an idea, you're not sure why they have that idea in the first place. You could not do a substantial part of physics, engineering, electrical engineering, biochemistry. You could not do a lot of these different things without a definition of the square root of a negative number. They pop up an equation, and I need to be able to work with it. So a complex number, I first have to define what an imaginary number is. Let's do that. Because a complex number is made up of an imaginary piece and a real piece. So what the hell is an imaginary number?
It could be a negative.
It's not a unicorn number. It's not a number that you use in the Narnia.
It could be.
Square root of -1. Is that real?
No. So it's square root of negative numbers in our imaginary
Not
numbers.
real.
So it's defined to make it easier to work with. We define it to be I. And in fact, I can do that any damn time you want to. What is square root of -1? Do you know?
Nope.
So let's call it variable, because what do we use variables for? Things I don't know. So it's really just making it easier to write. I is this. There you go. That's what I'm defining it to be. Just like pi is defined to be a certain real number, I is defined to be this complex number.
Can you square an I?
So there's really no wrong.
I love the question.
Square
So you-
I.
There's really no wrong answer.
Oh, hell yeah. Now you just got more ways to be wrong. You gotta be careful. I don't want to make you feel bad, but complex numbers are in themselves, they make sense. They're consistent with themselves. As a student, it kind of sucks they made the word imaginary number. Because as a student, you kind of discount it. Like, what the hell? Okay, math sucks. And now the teacher's freaking telling me there's freaking imaginary numbers. Okay, these idiots, I don't know what these people are doing, right? We want job security, so we make up weird shit so I still have a job. No. So I is this. Pat had a really good question. She said, what would you do if you squared I? So I squared.
And you could possibly get a real number.
Is 1?
Square root of -1 squared, right? What does a square and a square root do?
1.
What does a square and a square root do?
They cancel, right?
They cancel each other. So you're left with.
Just -1.
So remember how I kept saying you can't square a real number and get a negative answer, right? There's no real number you can square and get a negative answer. Because it's an imaginary number that you square to get a negative answer. If I is the square root of -1, I squared must be -1. Child,
Oh,
please.
I was writing a memo down for the test.
And if I start here, again, what do I do to both sides to get rid of the square?
You got the square root it, correct?
Square root, so don't I get I is square root of -1? Okay, so it's consistent. I know that's freaky as hell,
Not really.
but it's the same thing as always. If I square it, it kills the square root. Imaginary numbers should not act like real numbers in some ways, because they're different groups of numbers, right? So imaginary numbers are the only numbers you can square and get negative answers.
I see what you mean by you can't have the square of a negative number be a negative, because you're multiplying it by that same number.
Exactly.
Negative times a negative is a positive.
So now I can do it with these.
There's no negative i's.
Sure, of course. All right. So let me show you, here's what a complex number is then. A complex number looks like this. Every number we've done so far, every number you've ever seen in your life is complex. Because it's got a real piece plus an imaginary piece. So let's do some concrete examples. Here's a complex number, 5 plus 2i. That is a complex number. What's the real piece?
The 5.
The 5. What's the imaginary piece?
2i.
11.
Well, the 2's a real number, so wouldn't you have 2 real numbers in it?
2i are 2 i's.
They're connected.
There's 2
Oh, okay.
imaginary numbers.
Oh, that's right, multiply.
2 is just the coefficient. Tell me how many of these I have, right? Okay. I probably just lost more of you, but I'm going to try to keep up.
So
This
how
is
do
an
we
evil.
solve?
Why every number that we've ever seen, like the number 17, that's not complex. Yeah, it is. That is 17 plus 0i. So every real number just has b equal to 0.
So this is real, or this is the imaginary?
These are complex numbers which are made of real and imaginary pieces.
How would you solve something like this then?
No solving, there's no equation there. It's just a number.
Oh, that's
So like, watch this. Little side example here. 3 plus 4 pi. Right?
Yeah.
Isn't that a number?
Yeah.
Yeah.
You could put pi in there as a decimal, but you can't put the whole decimal in there, can you?
No.
You can never get an exact. That's the only way to write it exactly. So it's just the same. It's really just 3 plus 4 of these, 5 plus 2 of these.
Or could you just write 4 times?
Why can't I put these together?
because
They're not like terms. This is real stuff. This is measure stuff. So it's going to have 2 pieces to it, right?
so in a way that is a number in a way.
Yeah. And here's another example of something we've seen before like this. 4 plus 7 square root of 3. Can you do anything with that?
You can't square root 7 or square root 3. I mean,
Yeah, you can't square root 3 nicely. It could be a decimal that would go forever, but screw that. That's what it is. 4 1s plus 7 root 3s. I can't do anything with that. So 5 1s, 5 real 1s, plus 2 imaginary i's. That's what that means. So on one level, these actually kind of kick ass.
So it can never be a prime number.
Yeah, I can't really do anything with it.
do
So now watch this. This is where it becomes really nice because I is basically a variable. It's got one little twist. I mean, x is a variable. What's x squared? Is that equal to anything? No.
we don't know what x is.
I is a variable, a very specific variable, not a variable really, but it specifically is square root of -1. And remember, what was I squared again? I love it, right? So whenever I square an x, I don't have to do anything with it. It's just x squared, right? But if I square an I, what do I have to replace it with?
Negative one.
A neg-
-1.
Cool. So here's some examples of why adding, subtracting complex numbers. These are nice. Believe it or not. I know most of you probably don't believe it, but what does your gut tell you about adding these two things here?
Combine like terms.
Foil.
Combine like terms. It's adding, not multiplying. We'll get to multiplying in a minute. So what would you get?
You get
You get
9.
Minus I.
So if like the team
plus
had
I.
2 wins and the Celtics had
Imaginary.
The addition sign in the middle is
That's it?
yeah.
That's it. Right?
Yes.
Remind me, what's 4 plus 3 radical 2 plus 5 minus 2 radical 2? What's that?
9.
9 plus radical 2, correct?
Would you do any more with that?
No.
Why not? They're not like theirs. Would you do anything more with that?
No.
Well, yeah. I mean, I don't mean to make it sound like you should, oh, come on, I understand it. I'm trying to show you that I's act a lot like stuff we've seen before. In fact, I is a radical, isn't it? It's radical -1. So it's going to act exactly like other radicals would. It's just I don't want to have to write square root of -1 all the time, so I decided to make it I. Just makes it easier to kind of keep track of. Okay. Now, somebody kind of got ahead of the game here, but what about foiling these bad boys? What about
It'd be the
2 minus 4i times 5 plus 3i?
it wouldn't be too much more different, would it?
Do it. Do it. There's only one thing that's different.
And
And
that's
there
the
were x's
multiplication.
in there.
Do the whole number by the imaginary number. You just do it normally?
Of course.
I just changed the I to the -1.
I is not equal to -1.
Oh.
It's
I
another.
is equal to square root of
Yeah,
-1.
but I'm just saying like, okay, well, 2 minus 4 parentheses -1 in
Square root.
Square, okay.
See, that's why we're replacing it with I. It's easier to keep track of I than square root of -1.
10 plus minus.
Yeah, what do I get? I get
10
10
minus 6i
plus 6i.
plus 6i, sorry.
Minus 20i. Minus 12i squared.
Now, two things you can do here. One is the like terms.
Right.
What do you get in the middle here?
Minus 14.
That problem
Minus
is
14.
that problem is actually factorable.
I squared is -1.
Dude, easy.
Yeah, what's I squared?
-1.
-1. See, that's the new step. It's not really new. if I have a variable, a true variable here, I would put the like terms and be done. I is not a variable, it's a specific value, a square root of -1. So if I see I squared, like I was saying earlier, the only new thing really is, you know what I squared is.
-1.
It's
So
-1.
makes
If
it
it was an
12
x squared, I don't know what the hell that is.
Okay.
But I squared is -1.
So it's 12 positive then.
So I get 10 minus 14i plus 12, which is
Negative
Which is
12.
22.
22 minus 49.
Minus 49.
49 minus 2.
Sweet.
Oh, 22. Oh, yeah.
And again, right here, what's -12 times -1?
Only when you see it in that form, and then you can convert it.
If it's complex numbers, that's how they work.
Okay.
Notice how two complex numbers multiply to be a
22.
complex number, right? So you should be able to write it in the form a plus bi. In this case, what's a?
Is the real number.
22. What's b?
14.
Or
-14. Yeah.
Just I want to know how we could I squared is equal to -1. How you get this number?
So I is square root of -1.
Yes.
When you square, what happens with the square and the square root? They cancel.
-1.
So I is always equal to -1.
Square root
Got to
negative.
ask that too.
Right? Does pi ever allow to change value? Can pi suddenly be 7 if it wants to be? Pi is freaking 3, 4, 1, 4, 1, 5, blah, 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 blah. That's as far as I want to memorize it, right? So I is always
-1.
square root of -1, unless they say, that's why we try not to use I as a variable. Because then people are like, okay, is it a letter or is it a freaking imaginary number? Right?
And that's what I was going to ask you too. I never changes value. It stays -1, square root of -1.
Square root of -1.
Regardless of anything.
Unless they say we're doing a problem where I is a variable. That's why we try to stay away from doing that.
Square root.
So it would say I, if someone wouldn't know that, they think, okay, I is the square root of -1, but it has to say variable.
All right. So in context, you have to figure out that we're dealing with complex numbers here. All right. You guys try this one.
Can I just say I stopped believing in imaginary numbers when I stopped believing in Santa Claus?
If you could prove to me that you knew about imaginary numbers when you believed in Santa Claus. Certainly.
That is freaking neat.
Your mom sends a little video. Here she is.
I don't believe in imaginary numbers.
Then I would, yeah.
Send it? Alright, cool.
Get to work on that.
Are you a basketball fan?
Yeah.
Celtics.
Yeah, no, we're not talking about that.
Poor performance, I'm
We'll
guessing.
see if the Lakers in the same
They're
situation.
down
today.
2. Down 1-2.
Oh, really?
Oh, I know. I remember that from earlier. Yeah.
Don't worry, Lakers will be back.
Lakers will be good.
Be careful now. What's
Yeah.
4 plus I plus
Boston lost their last 2 games.
To the Heat.
All right.
Yeah, but see, your team was 4-0 over spring break.
All right. Let's stay on track. We got a lot to cover here. What do you get when you multiply this out?
You get 4 minus 4i plus 5i minus 5i squared.
I like that you all came together at the end. Now, if I was just like x, I would just put together my middle terms, which would be.
Do it. I.
9i.
I.
Well, now I can do something extra because what is I squared?
Multiply by -1.
I squared is -1. Now, after this lecture, I always have somebody do the work, and everywhere they see an I, they put a -1. That's why I want to really catch that now. I is square root of -1. I squared then must be.
9 plus 1.
Ah.
So you get 4 plus I plus 5, 9 plus I. And you can put I plus 9, that's fine, but it's kind of like A plus BI is accepted. I plus 9, same thing. How we doing? So let me ask this question this way. What's the real part?
9.
What's the imaginary part?
I.
1 I. I love it. Right?
Okay.
So, let me try to inject a little world into this.
I.
You guys know
squared
electricity
Kathy.
and magnetism are related?
I squared cat.
Yeah.
You guys know that?
Yeah.
If you move a magnet near a wire, you'll create a current. I don't know if you guys knew that.
Yeah.
It's kind of nifty.
Electrical current.
So electricity and magnetism are always going together. They're kind of like side by side. In electromagnetism, if you do the equations, the real part would be related to the electric field, and the imaginary part would be related to the magnetic field. So there are, and again, we're obviously not going to do physics in here, but I want to show you that there are reasons why we weird-ass math and physics people, why we do these things. It makes the math easier to work. There is a reason for these. They carry information with them. I understand that I is imaginary, I understand. But in working the math out, they carry information. The fact that there's a 1 out there tells me something. In this whatever situation I'm in.
Magnetic field is imaginary number?
The imaginary piece of the equation would tell you what the magnetic field strength is. Okay. Yeah, it's kind of nifty. And again, I don't want to make you guys feel, okay, what the hell? Just to show you a real life application.
Just get my last class of the day out of the way right now. So if they were to have you solve like 7 or 8i, you'd have to figure out, okay, 8 times the square root of -1.
So here we go. I think you're asking this question. What do you guys think this is now? Couldn't do it before. In fact, the answer was not a real number.
2i.
I love it. It kicks ass. If you break this up, square root of 4 times square root of -1. Square root of 4 is
2.
Square root of -1 is I. What? So you can always break up a radical. We've done that before.
So
Remember when we did square root of 50? Isn't that square root of 25 times square root of 2?
yeah.
Square root of 25 I can do, square root of 2 I can't.
2.
Yeah.
Here, break that up as square root of 4 times square root of -1. Is that not true?
Yes.
Yeah.
Square root of 4 I can do.
Yeah.
Square root of -1 I can't, but I just give it a better name.
We know it's in
Wait, what about
I.
-50?
Alright, cool. How do we do that?
2 times 2 is 4.
It's that one over there with the
I.
I.
So, guys, on one level, you do the same work you would have done before, just at the end, you throw a freaking I in there. If you want to see the work, here's the work. I would break this up as
25.
square root of 25,
1 has to be.
square root of -1, square root of 2, right?
Right.
How's that? That all becomes -50, right?
Yeah.
Square root of 25 is
5.
square root of -1 is I. Square root of 2, I don't know.
So the I stays on the outside, correct?
Okay.
You have to. Something we're definitely not going to talk about here is what's the square root of I. Let's leave that one alone.
Thank you.
But
That one gets a little bit freakier.
something.
That's something.
Something.
So I really want you to see. What's the square root of 49?
7.
So what's the square root of -49?
7i.
7 freaking I, right?
So it's always going to be negative.
Before, like this one, we say not real number, but now we can't say.
Now you can say 7i because now you know the complex answer. Before we just could say not a real number because what's the only numbers we're allowed to use?
Positive.
Real numbers.
Oops.
All the real numbers for
But with the
That's
I,
Yeah.
So again, split this up. Isn't the square root of 49 times square root of -1, right?
Yeah.
What's the square root of 49?
7.
Square root of -1.
Good God, man.
Except,
It's not that
I
hard.
definitely want you to accept that square root of -1, we have decided to replace it with the symbol I. We do it just to make it easier to write this stuff down. It's easier to keep track of 8 I's than to just keep track of 8 square root of -1s. So that's one reason why we do it.
If I see either one, I'd be able to freak out.
So, I mean, I want you to understand, we did the problem that we weren't able to do before, but in the problem itself is saying, sure, we did it, but it's imaginary. We haven't lost sight of the fact that this is not a real number. The answer tells me, oh, I did something, but it's still an imaginary number. So it's not trying to mislead anybody. I'm not saying, there's my answer. I'm saying, well, there's an answer, but it's not real.
You don't have to keep the figure.
We'll come to that.
Okay.
All right.
This is I didn't do the minus one.
Try this one. save your ass?
Order of operations.
Complex numbers have to follow order operations also.
You can't do what you want.
Beautiful, right? You gotta multiply first
Yeah, you do.
before you add, right? We know that.
Plus 18. So, since you already know the I is -1, don't you just change the negative into a positive already?
Only if it's squared.
Yeah, you wouldn't want to change.
Once you get an I squared, you can replace it with -1. Now there's some shortcuts you can make. If you got like -8I squared, you know that's plus 8, right? Because I squared is -1, it's going to change the sign. I don't know if that's what you're saying, but there's obviously always shortcuts you can find. I try not to teach them because it's better if you make your own shortcuts. It makes more sense to you then.
You're telling us to be creative.
Yeah, you can have creativity in mathematics, believe it or not. So what do you guys get here?
15.
15.
Negative 18I plus 10I minus 12I squared.
Alright, so I get, now I can start putting stuff together, and what can I do with this guy?
Minus 8.
So let's see, we get 2 plus 15 so far, right? 17, what do we get here?
That's negative 8. Okay, that's
negative
8. Minus.
Okay, -5, minus 8.
Negative 13.
And then at the very end here I get minus 12 times
Minus 1.
11. 12. So right there, if you wanted to, you could skip this step. So you know it's going to be changing the sign.
In the middle, instead of I, we cannot say root minus 1?
No, don't.
30.
You could, but don't. It's accepted to write an I. We don't write square root of -1, we write I.
29 plus 13I.
29 minus
So, yeah, 29 minus 13.
So, real quick, if I had a bunch of square roots running around, this big old long ass, and there's maybe some x's in there, and blah blah blah. I mean, it's hard to, can you see the complex number? Of course you can, but can you see it like that? No, but if I wrote this piece with an I instead, then then you'll be able to see the I easier. So writing an I instead of radical -1 helps you pick out the complex parts, help you pick out the imaginary parts, right? Yet another reason why we don't want to write square root of -1, we want to write I. It's easier to keep track and find those imaginary parts.
Did you solve this last one?
No.
What's the matter? Where are we at?
Root 7.
Oh, this here?
No?
It's an example. Forget it.
No, exactly.
Good Lord. All right.
Will the word factoring come into play here in the near future?
Say again?
Will the word factoring come into play here in the near future, I'm going to guess?
You know it will. What do you think you do with this one here? Besides runaway screen.
You're going to cancel the 3.
No.
Oh, that's not a light.
That
It has to be 3.
Don't make me cry.
You know, you go square it and then.
What's that? What is an I again? It's an I is.
Square root of -1.
We can multiply it by
It's a radical, right?
plus.
So what do you do when you have radicals in the bottom of a fraction?
Flip it.
Multiply
Flip it.
Multiply it by 4 plus 3i.
You multiply by the conjugate,
Now it's getting weird.
right?
4 minus 3i.
So times 4, and careful,
Yeah.
plus 3i.
Yes.
So you're going to multiply by its,
Just like,
Now it's getting weird.
when you,
recall. Oops. What did we do here? Get in there.
get in there.
What would you do there to rationalize the denominator?
Multiply it by the.
Just square root of 2.
Multiply by plus.
Multiply it by 4 plus 3 square root of 2. Because then the middle terms cancel, right? So you don't have any radicals left.
You have 1
So what's
equation.
going to happen here? Same idea. What's the middle term? Is it going to be imaginary? That sucks. What, doesn't it cancel there?
It's gone.
Negative 12i plus 12i is gone. So what do I end up with on the bottom then? I get 16 minus,
9i squared.
and what do I get on the top? I get 12 plus 9i.
Now you can't cancel the 9i because it has to be squared.
Negative 1.
I squared is negative 1, so I get 16 plus 9, right?
Yeah, 4, 1.
Whoa, 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 whoa.
Freaky.
Here's one thing though. 9i squared, you can cancel one of them because
No, again,
Oh.
division can only
We're not
cancel what?
multiplication.
Yes, and I have additions running around. I can't cancel that. That's exactly what we were just doing in the last section. Same thing. So whenever you see now, incredibly enough, this is called the complex conjugate because it's a conjugate. Conjugate just means it's got a different sign.
Yeah.
To make it like a difference of squares, so the middle terms go away. All the ugliness in the middle terms cancels. It's called a complex conjugate because it's freaking complex numbers, right? It's exactly what I do with radicals. I don't like radicals; they're ugly. So if I multiply with a conjugate, I kill the radicals, right? The middle piece dies. Same exact idea. Same exact idea.
How do you know what part of the bottom's multiply? Multiply out to out and in to in,
You're
basically?
talking about you foil like always.
Okay, so in to in, out to out. Okay.
Okay.
Inside numbers, outside numbers.
So here, guys, try this one.
You're dreaming, you'll wake up soon enough.
2 plus I over 3 minus 2I.
Don't you put the reciprocal on top now, the same as you did over there?
Not reciprocal.
The
Conjugate.
So you would 3 plus 2I on top?
Yes.
Divided by 3 plus 2I.
That's all you do. And then you multiply them out. So here's the conjugate, 3 plus 2i.
Yeah.
Yes.
Is like the difference of squares piece, right? 3 minus 2i, 3 plus 2i. So I guarantee the middle term is going to cancel. So on the top I get a bunch of stuff, right? I have to multiply this out. On the bottom I'm going to get 9 minus 6i plus 6i, it cancels.
Minus 4i squared.
Minus 4i squared.
Add, or and then changes it to plus 4i.
So again?
You change the sign, you go to multiply, right?
I multiply by the conjugate, which really just means change the sign. Right? And if I do that, the middle term cancels. The middle term is where the imaginary pieces would be, isn't it? And it cancels. Awesome. So I've kind of like made my bottoms real.
So the bottom actually equals 13.
Yeah, now it's going to be 9 plus 4 down here, 13. And on the top, I just got to multiply this bad boy out. 6, 4i, 3i, plus 2i squared.
2 minus, multiplied by negative 1. 6 plus negative 2.
You get 6 plus 7i.
Minus 2.
Minus 2.
Plus 2I squared.
Over 13.
So you get 4 plus 7i over 13.
Alright.
I spoiled you guys. I'm not done.
Yes, you are. Oh,
You could be done.
you
Good
win.
answer.
You win.
Alright. So last idea for the day.
Not like that.
Last idea for the day. I love you guys.
I was done an hour ago.
Alright, so you're sitting there.
No.
What do I get when I square that?
X plus 3 and x plus 3.
Okay.
So x squared plus 6 plus 9. Or 6x, I'm sorry.
Is that cool?
Yeah.
Yeah.
How is 6 related to that 3?
You add it
There's
twice.
two,
Twice.
two threes in
How is 9 related to that 3?
It's squared.
3.
So this 6 is 2 times the 3 here, right?
Yeah.
And this 9 is that 3
Times another
squared. All right, now watch. What's x plus 4 squared?
X plus 4.
8x plus 16.
Did you see the same pattern?
Yeah.
The middle guy is twice that, and the last guy is that guy
Squared.
squared. Right? Okay. So here, do I really have to do any work then?
You know what it's going to end up being. 10x plus 25.
I love it. Right? And that's all old. Here's the new stuff. If I had this, what would I have to put there and how would it factor? So that's doing it backwards now.
Difference of square.
So remember, we're always at a 10 because it's
5.
36.
twice 5, right? It's 10.
X plus 6.
All right, let me catch up to you. 10 is twice 5. 8 is twice 4. So if I don't know what that number is, and I just know that number like I do here, that's 12. What must be in here?
6.
6, because that 12 is twice 6.
36.
36.
And what number has to go there? It's got to be that 6 squared. 36. And sure enough, that's how that factors, right?
That's pretty cool.
So watch this. Last thing.
X plus 7.
It'd be 49.
So it'd be a two-step process. If you take half of negative 14, you get negative 7, right?
Yeah.
And that's what goes in here. That goes here. And how you get the number has to go there?
Plus 40.
You square what you just got.
Difference is squared, right?
So that's called completing the square. I put a number here so that I can factor it as a square.
Now what if you don't know the middle number?
That would be incredibly useful.
Now what if you don't know the middle number, or
Well, obviously you have to know that.
Okay.
If there is no middle number, there's no reason to do it, actually. All right, guys. Oh, yeah, you got the practice test, right? Yeah. That's why I did that. I knew I'd forget if I didn't.
37 minutes.